Welcome to this tutorial for group sequential design and unblinded sample size re-estimation in nQuery. In this tutorial, we will cover how to calculate the sample size for a group sequential design comparing two means and show how this can be extended to allow for unblinded sample size re-estimation if the interim effect size is promising. To do this, we are going to replicate an example of a group sequential design for the comparison of two means from the New England Journal of Medicine comparing Botox against anticholinergic therapy for the treatment of urinary incontinence. The group sequential design is the most widely used type of adaptive design in phase 3 clinical trials. In a group sequential design, at pre-specified times, we look at the interim effect size and decide if the evidence is very strongly for or against our treatment being effective. And based on this evidence, we have the option to stop our trial early if this evidence is strong enough. By using a flexible spending function approach, we have a great deal of control over how likely we are to stop at a given interim analysis. And thus, if our treatment is effective, we have the chance to stop our trial early and get to market quicker, or if our treatment is ineffective, to stop a trial early and reduce the cost of the trial overall and reduce the exposure of patients to an ineffective treatment. In nQuery, a group sequential design sample size requires us to fill in two sets of inputs: the fixed term inputs and the group sequential inputs. The fixed term inputs are in the top left table. These are equivalent to the same inputs that we required for a fixed term analysis, in this case a z-test since we are comparing means. We simply fill in each column based on the definition of each row given on the far left hand column, and that will then be sufficient to do a group sequential design once we have specified how we want that group sequential design to be. In this particular example, the researchers had a 0.05 significance level at the two-sided level with means of -1.5 and -2.3 in each group. There was a common standard deviation of 2.1 and a sample size ratio of 1, which is the default. Before we enter the power, let's enter the group sequential design parameters. These are contained in the look side table, which is directly below the fixed term inputs in the main table in the top left hand corner. The look side table can be split into two parts. On the left hand side are the inputs or rules that we will use to define our group sequential design. On the right hand side are the outputs, which will tell us the boundaries that will allow us to stop early at a given interim analysis and how likely we are to stop early based on either the null or alternative hypothesis being true. In this particular example, the researchers had a single interim analysis, which meant that there was 2 looks in total. And these were equally spaced, meaning that after 50% of the data was collected, they would do an interim analysis. If we wanted to use a custom approach, we could select user input from this row and then enter these into the table on the right hand side manually. We then choose the error spending approach that we want to use. In this case, they did not use a futility bound, so we will keep that at the default of don't calculate. And the efficacy bound that they used was an O'Brien-Fleming spending function, which is a default in nQuery. However, note that there are other options for doing a spending function, including setting your own custom boundaries. Having replicated the rules of their group sequential design, we will now enter a power of 80% into the main table, giving a sample size of 109, which is equivalent to the sample size expected by these researchers. You will see that in the look side table, the right-hand table has now been fully occupied. In this case, we can see that the lower efficacy bound and upper efficacy bound are equal to 2.963. This means that if the standardized z-statistic at an interim analysis was equal or between -2.963 and 2.963, we would choose to continue the trial to the next look. However, if it was below -2.963 or above 2.963, we would stop early for efficacy at this look. This is equivalent if we were doing a two-sided z-test on the interim analysis to achieving a significance level of 0.003 or less. In other words, if we have a p-value less than 0.003 based on a z-test of the interim analysis, interim data, then we would stop the trial early. Let's now extend this example to allow for a futility analysis. To do so, let's do this analysis at the one-sided level but at an equivalent alpha by halving 0.05 to 0.025. We will keep the other parameters the same, and then replicate the same group sequential design with 2 looks and an O'Brien-Fleming spending function. In this case, let's add a futility boundary that is non-binding. This means that if we cross the futility bound, we still have the opportunity to continue our trial to the next look without affecting the overall type 1 error. In this case, we'll use a more flexible spending function for the futility bound using the Huang-Shi-Dekani approach, and set its gamma parameter to -1.5. We will now set the power to 80% for this example as well. And this gives a sample size of 114 per group, which is slightly higher, but we also now have the optionality of stopping our trial for futility. You can see that the efficacy bound is approximately 2.963. This means if the standardized z-statistic at the interim analysis is above 2.963, then we would stop for efficacy. But if it is below 0.508, then we have the option to stop early for futility. At the final look, you can see that the two bounds are the same. In other words, depending on whether we're above or below 1.969, we would either be efficacious or futile, based on the p-value there of being above or below 0.024. Now that we've done a group sequential design, let's see how this could be extended to allow for an unblinded sample size re-estimation. To do this in nQuery, we simply need to select the interim monitoring and sample size re-estimation button. This will open up a new table which allows for unblinded sample size re-estimation and interim monitoring. This table is quite similar to the group sequential design, where on the left-hand side, we have the rules for when and where to do a sample size re-estimation, and on the right-hand side, we enter what happened at each interim analysis, and it will decide based on the rules whether to stop early, continue to the next look, or increase the sample size. We can thus see that that third option is really just an extension of the group sequential design framework. In nQuery, there are two different approaches for sample size re-estimation, which are collectively often called promising zone designs. In this case, they are known as the Chen, Demetz and Lan and Cui, Hung and Wang approach. In this tutorial, we will mostly focus on the Chen, Demetz and Lan approach. The main difference between these approaches is that the Chen, Demetz and Lan approach must do a sample size re-estimation at the penultimate analysis, and the conditional power must be between two very specific maximum and minimum conditional power bounds. Whereas the Cui, Hung and Wang approach is much more flexible, but relies on using a weighted statistic that is distinct from that would be used for a group sequential design. In this case, we've selected the Chen, Demetz and Lan approach, and the interim analysis will be at look number 1, which is equivalent to the column number in the right-hand side table. We can select the maximum allowable sample size that we would want to use in this study, the default of which is double the original sample size that we had for a group sequential design. We can then choose that if we are in the promising zone, as defined here, between the minimum and maximum conditional powers for sample size re-estimation, whether we want to only increase sample size until the conditional power is equal to the original target power, or we can increase immediately to the maximum n specified above. We can then set what that target conditional power is in this row. And then we set the bounds for when we want a sample size re-estimation to occur. For reference, the conditional power is the probability at an interim analysis that we would have a significant result by the end of the study. For a Chen-Dimension-Lan approach, the range with which we are allowed to increase the sample size is very restrictive. In this case, the default is the Chen-Dimension-Lan approach, where it must be above 50% to guarantee type 1 error control. However, work by Mehta and Pocock can be used to define the exact limit for a specific group sequential design above which you are allowed to do sample size re-estimation, with the previous 50% rule being the minimum band that you need for any group sequential design, whereas this is tailored to the specific design we're looking at today. You can see here that that's reduced from 50% down to 35.7%. Now that we've defined the rules for when we want to do a sample size re-estimation, which is at the first look, we're going to allow the sample size to increase by at most double, and only if the conditional power is between 35.7 and 80%, and we want to increase sample size until the conditional power is equal to 80%, the original target power from the group sequential design. We now want to fill what happened at each interim analysis and final analysis in nQuery. In this case, let's assume that there was a 25% reduction in our effect size compared to the original design. In other words, an interim effect size of 0.6. Next, let's assume that there's a 10% increase in the standard deviation in each group, which is equivalent to 2.31 standard deviation in each group. This gives an interim test statistic, Z statistic, of 1.387. This is between the upper efficacy bound and the futility bound, therefore we want to continue to the next look. However, we can also see that the conditional power falls between 35.7 and 80%, and thus nQuery recommends that you increase the sample size up to 429 to ensure that your conditional power is now equal to 80%. So this has increased the sample size from 228 up to 429 automatically for us in nQuery. Now that we've done the interim analysis, let's see what happens at the final analysis, assuming that the interim effect size and the standard deviations we saw at the interim analysis were the correct ones of 0.6 and 2.31 respectively. We can see that we get a final test statistic of 2.69, which is above 1.969, and thus we find for efficacy. However, if we were to do the same example, but without an unblinded sample size re-estimation, which we can do by selecting none from the sample size re-estimation method, if we had that same interim effect size, in this case, because sample size re-estimation has been removed, it will simply recommend that we continue. You'll see that the sample size is at its original value of 228. And if we have the same effect size at the end, we end up with a test statistic of 1.961, which in this case is below 1.969, and therefore we would have found for futility. Therefore, we can see that by increasing the sample size in this particular effect size, we have actually got a significant value only if we had done the sample size re-estimation, and otherwise would have got a non-significant result. This is why it's often called a promising zone result, because as your effect size is still promising, in this case 0.6 is considered promising, we have ensured that this promising result is still saved from being non-significant in an equivalent group sequential design. To learn more, visit statsolves.com. Thank you for watching.